Okay, so we've got a question here. A box is pulled at an angle of 15 degrees with a force of 5 newtons. The coefficient of friction is 0.1. And what we want to find is the mass of the box if it's all in a state of equilibrium. So to calculate this, the first thing we're going to do is draw a forces diagram. So that's my horizontal plane. And let's let this represent the box of a mass m which we need to find. Now it's being pulled at 5 newtons at 15 degrees. So let's draw that force there. So that's 5 newtons and my angle there is 15 degrees. Okay, well the force acting on that box, apart from the one that's written in the question, is going to be the force of gravity. So that'll be mass times the gravitational constant, which we are given here, which is 9.8, which is what it normally is. So for it to be in a state of equilibrium, what we need is opposing forces to equal these forces. So we'll have a vertical force, which will be the resulting vertical force, and a force along the horizontal plane, which I'm going to call F. Now the coefficient of friction is 0.1, so I'll just write that as 1 over 10. So what we need to happen is our force, F, to be less than or equal to coefficient of friction times the resulting vertical force. Okay, so that's our goal. So let's work out first this force here. So F equals, now what we need here is this corresponding force along this line here. Now if we just draw a line down there and use trigonometry, as this is adjacent to the 15 degrees, we can use cosine. So therefore our force here is 5 times the cosine of 15 degrees. Okay, now what about our force R? So R, that's going to be this force here, so M times G. So M times G minus the force that is acting when it's being pulled by here. Now, as we've got 15 degrees as our angle, we can use sine of 15 degrees times 5 newtons. So we'll have 5 times sine of 15 degrees. Okay, now what we need is our force to be less than or equal to mu times r. So if force is less than mu, which is 1/10, times r, which is mg, minus 5 times sine of 15 degrees. So our goal now is to get this m isolated. Okay, so F is 5 times cosine of 15. So 5 times cosine of 15 degrees is less than or equal to mg over 10, distributing this 10, and then divide 5 by 10, so we'll have a half of sine 15. So minus a half of sine 15 degrees. Okay, let's bring this one over to this side. So I'll now have 5 cosine of 15 plus 1/2 of sine 15, and that's going to be less than or equal to mg over 10. Okay, now let's get m on its own. So if I multiply both sides by 10 over g, so now I will have 10 over g times 5 cosine of 15 plus a half sine 15. That's going to be less than my mass of my box. Okay, let's distribute the 10. So let's carry this up over here. Let's distribute the 10 and divide everybody by g. So I'll have 50 cosine 15 plus 5 sine 15, and then divide that by g. G is 9.8. So that's divided by 9.8. And that will be, my mass will be larger than whatever we get here. So let's just put that in there. So mass is larger than or equal to that calculation there. So let's put that in our calculator and see what we get. So 50 cosine 15 plus 5 sine 15, and then divide that by 9.8. So we get 5.06 approximately. So the mass of my box is greater than 5.06, and that will be in kilograms. So that would be the answer to our question. That would be the mass of the box. Okay.